When the Hubble Space Telescope turned its patient eye toward the faint traveler named 3I/ATLAS, astronomers expected familiarity. A bright nucleus, a dusty tail flowing away from the sun, light scattering gently across the curve of its motion. That's how comets behave. They visit, they shine, they fade. But what appeared on Hubble's screen wasn't a comet at all, at least not in any sense we've ever known. Instead of trailing dust behind it, 3I/ATLAS glowed in front, a hazy orb of light leading its path through the dark, a comet shining the wrong way, a glow that should not exist. The moment scientists saw it, they realized something fundamental was broken. Something about the universe had just whispered, "Look again." Comets are supposed to follow rules. They orbit stars, heat up, release gas, form tails, one of dust, one of ions, both streaming behind them as sunlight and solar wind push material outward. These are not guesses or models, they are laws of motion written across decades of observation. Yet there it was, a luminous mist forming ahead of 3/ATLAS's direction, as if the comet were carrying a headlight into the void. It wasn't just strange, it was impossible. And if this glow was real, it meant something inside our cosmic textbook was about to be rewritten. Scientists scrambled for explanations. Maybe it was an optical illusion, a trick of perspective. Perhaps the tail simply pointed straight toward us, compressed into a single beam of light. But more data ruled that out. The orientation didn't match, and even ultraviolet images, where ion tails should blaze most clearly, showed the same thing, a forward-facing glow. For decades, every comet we've studied has behaved like clockwork, but this one, this quiet visitor from beyond our sun's influence, was defying physics itself. If this behavior was genuine, the consequences stretch far beyond a single object. Because if 3I/ATLAS could emit light ahead of its motion, then something about how interstellar objects interact with solar energy had to be reconsidered. The stakes were enormous. Comets are messengers, archives of chemical history frozen for billions of years. They carry information from the birth of stars, the chemistry of other systems, even the origins of life. If one of them disobeyed the rules, it could mean that the forces we take for granted, radiation pressure, solar wind, ionization, behave differently across the galaxy. The sun's reach might not be as predictable as we believe, and the universe, once again, was reminding us how little we truly understand. To make sense of it, scientists looked back at where this story began. 3I/ATLAS, officially designated C/2024A1, is no ordinary comet. It is an interstellar object, the third ever discovered following the mysterious Oumuamua in 2017 and 2I/Borisov in 2019. That little 3I means third interstellar. It does not belong to our solar family. It was forged around another star, in another time, in another system, perhaps hundreds of light years away. Long ago, some cosmic upheaval hurled it into the dark, flinging it through interstellar space, where it drifted for millions, maybe billions of years before crossing paths with the sun. In that sense, 3I/ATLAS is a time capsule, a messenger carrying the chemistry of another world. Each of its predecessors had told a strange story. Oumuamua, a cigar-shaped rock that tumbled end over end and mysteriously accelerated as it left, with no visible outgassing to explain the push. Borisov, more familiar in appearance with a tail and coma, yet more active than any comet seen at similar distances. And now, 3I/A TLAS, glowing not behind but in front as though illuminating its own path. Each interstellar visitor seemed to arrive carrying its own riddle, its own contradiction, its own quiet defiance of how space should behave. When Hubble's images first arrived, scientists noticed two things. The first was the absence of a clear tail. The second, the bright, almost circular haze ahead of the nucleus. When they plotted its brightness over time, they expected smooth oscillations, the kind caused by sunlight reflecting off a rotating body. Instead, the light fluctuated irregularly, unpredictable, chaotic, alive. Something about 3I/ATLAS refused symmetry. It refused pattern. The cosmos had delivered a visitor that followed none of the ordinary paths. One idea came quickly: electrostatic charging. Perhaps the dust particles ejected from 3I/ATLAS were so fine and so strongly charged that instead of being pushed backward, they were drawn forward along magnetic field lines shaped by the solar wind that could, in theory, create a glow-ahead effect. But the math was ugly. For the glow to appear that bright, the dust would need to be smaller than any grain ever measured and perfectly aligned with solar fields. It wasn't impossible, but it was implausible. Another theory focused on gas jets, volatile pockets on the surface releasing vapor like rocket thrusters, perhaps pointing forward instead of backward. Comets often have jets, but they usually fan outward at random, not in a single coherent stream. For 3I/ATLAS, those jets would have to fire with precise coordination, as if the object were venting material directly into its path. The scenario strained credibility, yet it remained on the list. Then came the most dramatic possibility, that 3I/ATLAS was surrounded by a plasma bow shock, a luminous wave forming ahead of it as it tore through the charged particles of the solar wind. In essence, the comet could be acting like a spacecraft entering Earth's atmosphere, creating a shock wave of heated plasma that glows visibly as it compresses. If that were true, it would mark the first time in human history that astronomers have witnessed a visible bow shock around an interstellar object within our solar system. The implications were extraordinary. A bow shock means that matter from another star system is colliding softly, electrically, luminously with matter from ours. Two stellar environments meeting in a shimmering frontier. The front of 3I/ATLAS would be heated and ionized, the gases excited to glow invisible light, forming the eerie forward haze captured by Hubble. In that interpretation, the glow wasn't a reflection at all. It was a collision, a dialogue between alien dust and solar wind. When astronomers measured its speed, the numbers deepened the mystery. Over 60 kilometers per second relative to the Sun, faster than most known comets. At such speed, every solar proton that struck its surface carried immense energy. The bombardment could easily ionize gases, create plasma, and drive exotic chemistry. But even then, something remained wrong. A bow shock should create turbulence behind it, a wake of ionized dust. Yet no tail trailed 3I/ATLAS. The rear remained eerily clean, as though the material leaving its surface was instantly neutralized or perfectly balanced. That perfect symmetry suggested forces we hadn't yet measured, perhaps electromagnetic fields, perhaps the composition of the object itself. The coma, that glowing cloud around the core, wasn't stretched like a teardrop, but almost spherical, suggesting an internal pressure or reinforcement mechanism. Was 3 I/A T LAS magnetized? Was it encased in metallic compounds that interacted differently with light? Every answer opened another door. As the days passed, telescopes across the globe joined in. The Subaru telescope in Hawaii, the Very Large Telescope in Chile, even spacecraft in orbit turned their gaze toward this anomaly. And soon, all eyes turned to the James Webb Space Telescope, whose infrared instruments could probe the unseen, the warmth beneath the glow. If the forward light came from chemical reactions, Webb's sensors could detect specific heat signatures. If it was plasma, the telescope would catch distinct emission lines, the fingerprints of ionized gas. Somewhere in that data lay the truth. But what if the truth was even stranger than the theories suggested? Consider this: interstellar objects are fragments of alien worlds carrying dust and ices formed around other stars. Their chemical compositions are not bound by our solar norms. What if the glow wasn't a result of the sun's influence at all, but of something internal? Some exotic element or compound reacting differently to solar radiation? What if 3 I/A T LAS carried materials that fluoresced, reflecting light in directions our physics doesn't expect? That question is more than poetic curiosity, it is scientific necessity, because every new interstellar visitor has expanded the boundaries of what we thought possible. Oumuamua blurred the line between comet and asteroid. Borisov showed us that comets from other systems can be more volatile, more alive. And 3 I/A T LAS. It might be teaching us that interstellar matter behaves under solar pressure in ways we've never seen. Perhaps the chemistry of distant suns breeds materials with properties foreign to our own. Perhaps the sun's influence, its radiation, its magnetic breath, reveals those secrets in the glow of alien dust. The scientific world waits now, as Webb and Hubble trade data, as observatories refine measurements. The shape of the glow, the wavelengths of its light, the subtle variations in brightness, all will tell us whether we're watching plasma physics, chemistry, or something altogether new. Whatever emerges, one truth already stands. 3 I/A T LAS has rewritten the story of interstellar visitors. And what a story it is. Imagine a frozen fragment ejected from another solar nursery long before humanity existed, wandering the void between stars for eons, then passing close enough for us to glimpse it just once. During that brief encounter, it reveals a behavior no one predicted, shining in defiance of cosmic convention. It's a reminder that the universe still holds surprises, that even after centuries of astronomy, the sky can still whisper, "You don't know me yet." If the glow turns out to be a bow shock, we will have witnessed the literal meeting of two stellar systems, not through collision, but through energy exchange. A silent handshake between worlds separated by light years. The interstellar medium, carrying dust and ions from another sun, now meeting our own solar wind in a luminous arc. That would make 3 I/A T LAS the first confirmed instance of direct interaction between two stellar domains observed in visible light. But if the glow is chemical, the revelation may be equally profound. It would mean we are watching alien chemistry in real time. Compounds formed under another sun reacting with ours. Molecules that have never existed within the boundaries of the solar system suddenly igniting, glowing, transforming as they meet our light. In that sense, 3 I/A T LAS is both visitor and experiment, a natural laboratory drifting through the sun's influence, carrying lessons from across the galaxy. Scientists know this. Every observation counts. As the object approaches perihelion, the point nearest the sun, its brightness could spike, its composition could change, its glow could reveal the truth. Yet even if it disintegrates, as many comets do, it will leave data behind, traces that tell us what it was made of, how it behaved, and how interstellar matter survives the furnace of a foreign star. Each fragment will become a message. Still, beyond the data and equations, there's another side to this story, the human side. For every scientist poring over numbers, there's a child looking up, wondering how something so small and distant can capture our attention across the vastness of space. 3. I/A-T-L-A-S reminds us why we explore. Not because the answers are easy, but because they are unknown. It's in our nature to chase mysteries, to follow the light even when it burns in the wrong direction. In the quiet language of astronomy, 3I/A-T-L-A-S speaks of connection. Every time we detect an interstellar visitor, we prove that our solar system is not isolated. It's part of a galactic ecosystem where debris, ice, and rock drift endlessly between suns. Somewhere, another civilization, if it exists, might be watching one of our comets pass by their skies, wondering the same things we wonder now. These travelers are our messengers and our mirrors. Imagine how many more might be out there, invisible against the black. If we found 3 in less than a decade, there could be millions moving silently between the stars, carrying the dust of distant planets, the fingerprints of alien chemistry. 3I/A-T-L-A-S, glowing ahead instead of behind, may simply be the one we happen to notice, the one that dared to shine differently enough for us to see. In that sense, its defiance is poetic. It challenges the notion of predictability, the comfort of known laws. It says that even in the age of supercomputers and